Okay, hello again. Tonight we're going to be talking about great circle sailings, right? And so if you've watched some of the other videos, you've seen parallel sailings and mid-latitude sailings. Tonight we're talking great circle sailings. It really has nothing to do with sailboats or anything like that. More about having to traverse a large distance over a spherical Earth is what we're talking about there. So let's get started. All right. So imagine you had to cover a large distance on the surface of the Earth. For instance, say you wanted to go from Tasmania over to South Africa. Right, that looks like a pretty straight line, if I can orient it right for you there. Pretty straight line, right, between the 2 points. Well, if you turn it on its side and start looking at it this way, you can see that it kind of makes actually a big curve. Right, and that big curve depends on the orientation of how you're looking at things and the projection of the chart that you're looking at. So the quickest path between any 2 points on the surface of a sphere, assuming you believe in a spherical Earth, I guess, is a great circle. So it's a straight line. If you were to cut the Earth in half with a lightsaber right through the middle of the Earth and then back out the other side, the path traced along the crust is going to be a great circle path. And so if you've ever taken a long distance plane ride and you've seen it appear to curve to the north or to the south, that's what we're getting after there, right? So it always curves poleward to the North Pole or towards the South Pole. So depending on your positions, the Great Circle track can be significantly different than what you might think. It might take you into really northern or really southern waters, and you might not be prepared for that. So one of the calculations we can do is figuring out exactly how far north or south you're going to get on a Great Circle path. The most poleward, killed a pen. The most poleward point is called the vertex. It can occur in either hemisphere. The most poleward, or the closest you get to the North Pole or to the South Pole, is called the vertex. And the vertex has a latitude and a longitude. It might be called LV and lambda V for the position of the vertex. On the Great Circle track, there's an origin and there's a destination. Latitude 1, longitude 1, latitude 2, longitude 2. And then along the path, there's going to be a vertex. So as a mariner, you might want to know a little bit about where that vertex is to let you know, hey, am I going into the Bering Sea or into the Southern Ocean? I want to be aware of that before I make this trip. The two positions, 1 and 2, correspond just to latitudes and longitudes. And then depending on the type of problem that you see on your Coast Guard exam, there's like 3 or 4 things that they can ask you. So a good understanding of general Great Circle sailing, including problems about the latitude and the longitude of the vertex, is going to be critical for you. So a couple of other terms we need to talk about. D is going to stand for distance, and that's going to be in nautical miles. And then C is going to stand for course. And for a great circle, you're not steering the same course the entire time. If you were to leave position 1 and just steer a course of, say, 045 degrees true, you would wind your way up towards the North Pole. That would be a rhumb line and a loxodromic navigation or a loxodromic course. We're going to do great circle sailing, which is orthodromic sailing, and we're going to change our course as we go along. So your initial course is what we're getting after here. Your initial course, the one you set out on. As the path progresses, you need to continually turn towards your new destination. So it's going to be a succession of courses to get the Great Circle route and the maximum efficiency there. One thing about the courses that we need to talk about before we get into the problem is going to be this thing called course angle notation. And it's not a huge deal, but if this is our general compass here, 180 south, 270 west, you might say that a course of 330, let's say, degrees true, would look something like that. That would be 330 degrees true. And that might be your initial course angle, 330 degrees true. Well, if we want the math to work out just right, we actually have to put this in different terms, because truthfully, that is 330, right, around the compass. But mathematically, for the Great Circle stuff, we're interested in this angle right here, right? So it's called CN, or course angle. And the way that you name these courses is you start with the northern or the southern pole. So in this case, it would be the north. And then how far off of that course are you? So in this case, it would be 360 minus 330, or 30 degrees. And then in what direction? To the east, to the west. All right, so this north 30 west is the same thing as 330 degrees true. And luckily, if you were to type this into a calculator, and I'm going to take a moment just to show you that. If you were to type, say, 330 into the calculator and then hit the cosine of it, you're going to get this number decimal 866. Right? But if you do the same thing with 30, you get the same exact number. Sometimes the signs get mixed up, but the numbers work out. So if you can't remember the course angle notation, if you type in the course itself, you're going to get approximately the right number. You might just need to logic out whether you're going east or going west. All right, so if you look in the video description box here on YouTube, or if you're watching in the future in the attached documents, we're going to talk about a problem where we start here at this position, we go to this position with a course and distance given, and we want to know what the latitude and the longitude of the vertex is. We want to know exactly where that point is that's most poleward, right? And so the first steps we're going to have here are going to be, not all of this is completely necessary, but I always like to convert all these into decimal notation, right? You're only going to use some of them, but the way we're going to do that is I'm going to take the 50 leftover minutes there and divide that by 60 to get a decimal. So it's actually 25.833 degrees north. Right, so this way we can type all this stuff into our calculator and get stuff done that way. 77 degrees west is just going to be 77.000 west. And then for these other ones, we'll do the same thing. So 56 divided by 60 is going to be 35.933 degrees north. And the 15, I can do that in my head, is going to be 06.250 degrees west. That's going to be helpful. Not all of them are required, but it's just a habit for me when I'm doing these types of problems. The next thing is going to be to deal with this course, right? And so for this course, we're heading off on 061.7 degrees true. And luckily, that's going to be the exact same course angle, so no change is necessary. But if you were curious, it's going to be equal to north 61.7 east. All right, so no change required, but it's a good habit to get into to turn all these things into course angle notation. And then from there, I hate to disappoint you, but a lot of this is simply plugging and chugging into a formula and then interpreting the results. So we're going to take a little detour and we're going to go look at my good friend Nathaniel Bowditch's book. Actually, I don't know Nathaniel Bowditch, but I imagine he was a great guy. Right, and so this is what's called Bowditch Volume 2, this book here, and it is available to you in the test room for Coast Guard exams. And so if you can get familiar with this text and know where to look up things, you can find all the formulas that you might need. So down here is an area talking about great circle, sailing by computation, and then right on the next page is a whole bunch of formulas. Right, so if you were to teach yourself this in the test, you would not be the first person to do that for sure. So all these formulas are stuff that I'm going to reference. Right, I'm not going to show you every time, but just know that it's all there. I'm not pulling this stuff just out of my head for sure. I could not do that if I tried. Right, so that book is available to you in the test room for Coast Guard exams. You can read about it and refresh yourself on that topic, and then have access to the formulas. However, you do need to know where to look in order to find them, because it is a thick book. So if I want the latitude of the vertex, how high am I going to get on that great circle path? Well, the formula that goes for that is going to be the cosine of the latitude of the vertex is equal to the cosine of the first latitude times the sine of your course. Right, and so we've got all that stuff, which is great. So we've got the course, 61.7. We can put that in right here for C. L1 is going to be our initial position. So why don't we just rename these for sake here? L1, L2, and then lambda for the longitudes. And we've got all of our positions. Right, so if you're watching in the future, you can fast forward through this, but we'll kind of just type everything into the calculator here. So the cosine of the latitude of the vertex is going to be equal to 25.833 times the cosine, which gives you 0.900. I like to go to 4 decimal places when I'm doing my Coast Guard exams. I always end up with the right answer that way, assuming I did the problem correctly. But you don't need to go necessarily too much further. You also need to know what type of calculator you can have in the exam room. And so one of these scientific calculators is going to do it for you. You can't take your phone in. You can't use a programmable calculator either. But if you are familiar with some of the memory functions in this, you can possibly save a little bit of time. But force of habit for me is I just kind of write down the numbers. So if you trust my ability to type in numbers on a calculator, I'll save you a little bit of time here. And for the sine of our course, we end up with 0.8805. And then if we multiply these two things together, cosine of the latitude of our vertex comes out at 0.792. All right, and so usually you can get pretty far, that far if you remember a little bit of your algebra and multiplication and stuff. But how do we actually get what we're interested in, which is the latitude of the vertex? Well, in order to do that, we got to use the calculator in a little different way. So I'm just going to take a little detour and show you how that's going to work. But in essence, the number that I need to type in is 0.7924. I'm going to do that, and then we'll show you on the calculator. I typed it in. So all the sine and cosine and tangent functions are here. These are all your trigonometric functions. Right? And then the inverse signs are right above them. So if you wanted to find the cosine of the latitude of your vertex, what we're going to do is need to get the inverse cosine of this 0.7924 number there. So what we'll do is we'll press shift and then cosine, and we get the negative cosine or the inverse cosine, 1 over cosine as it were. All right, so our number comes out as 37.589 degrees. And so that's not necessarily useful to us in that format. We just need to turn it over to like a real latitude number. So it's 37 degrees. And then we take the 0.589 and we multiply it by 60 to get the minutes that are left. So 37.35 minutes north latitude, which is cool. That's good to know, right? For if we're sailing. Yeah, so Gavin says Napier's rules got nothing on me. Thanks, appreciate that. Yeah, Napier's rules are all in the book. You can teach yourself all that stuff if you need to. Personally, I go right to the formula myself. But yeah, so we started at a latitude of 25.8 north. We ended at a latitude of 35.9 north. But the most north we got was 37 degrees 35 minutes north. Right, so it's a little bit further north than our destination. So if you weren't prepared to do that, or if you're going into waters that are colder or filled with icebergs kind of thing, this is the stuff that we want to know. How close to the pole are we getting on these journeys? You can also get the longitude of the vertex if you want. And actually, just thinking about it, like our second longitude is pretty close to this, right? So our latitude of the vertex is pretty close to the second latitude. So it's kind of a great circle path that's a little bit more than what you would consider half of a big great circle. So we're probably going to end up pretty close to the longitude number 2 for the longitude of the vertex. But there's a formula for that one as well. So let's write that down. So the formula for the longitude of the vertex is it's going to be related to what's called the difference in longitude, or DLO, another formula right from Bowditch. So rather than show it to you, I'll just draw it up here. And the formula is going to be the sine of the difference in longitude is equal to the cosine of the course over the sine of the latitude of the vertex. So in Bowditch, this is equation 27. The previous one for the latitude of the vertex was equation 25. So if you remember, all these equations are in the 20s and 30s that we're going to deal with tonight. So that's the place to look in Bowditch when you're dealing with that. Okay, so let's solve this one out. And again, rather than me typing into the computer or to the calculator, I'll just kind of trust that I can do that. But the sine of the difference in longitude, and what I mean by difference in longitude, I just mean literally the difference between these two longitudes. how far east or west are we going to get. And important to know though, like the distance of a difference in longitude towards the equator is much different than it is towards the pole. And that thing is called departure, which we've dealt with in other types of sailings, but not necessary for this one. So the cosine of the course comes out to be 0.4741. And the sine of the latitude of the vertex, so we found the latitude of the vertex in the last problem, is 0.6099. Okay. And then, so likewise, to get the difference in longitude, what we're looking for, we got to do the inverse sine of this number. So if you type all that stuff in, and then do shift sine, same way to get it there, you're going to get 51.0177 degrees. All right, and so I see a couple questions coming in there for John. Hey, John, nice to see you again. Long time no see. This is everything from 200 to unlimited tonnage. Just a slightly different version of some of the stuff that you and I did last week. This latitude of the vertex, though, it's on your test, so get ready. And then Adrian, Dan, hand up. Not sure if that's a question or just a high five. If it's a high five, thanks, man. Appreciate it. Okay, so our difference in longitude is a number of degrees, but that's not going to be, super helpful when we're trying to figure out an actual position. So it's 51 degrees, and again, we're going to turn that into minutes. So it's 51 degrees and 1.1 minutes to the east. All right, we said that initially. Our initial course was it 061.7? So 51 degrees to the east. So what you do is you take your first longitude, this one here, 77.00 degrees west, and then we're going to change it by 51.077, 0177 rather, to the east. And what's that new longitude going to be? Well, if we're out at 77 degrees west and we're going to the east, our longitude is going to get shorter or smaller as we go. So I guess I can calculate that. 77 minus 51.0177 is 25.9823. West longitude, which is equal to 25 degrees. And then 59 minutes. West longitude. Now we've got the longitude of the vertex as well. So in the first part of the problem, we did the latitude of the vertex. And John, if you're still watching, that's on your test for sure. In this part of the problem, we got the longitude of the vertex as well. So there's actually more we can do with this problem. I'm going to combine it with another one. But just to be safe, I'm gonna note the two things that we solved here. So the latitude of the vertex, what did that end up as? 37.5867 degrees north. And the longitude of the vertex we just got here was 25.9823 west. All right. So it's pretty fun stuff. I like it because it makes you feel pretty smart, even though you're just typing in numbers into a calculator there. So it's all good stuff. I think this was, yeah, good. So we got our latitude and longitude of the vertex. We got our two positions. We got our course and distance. You might think that's everything that's out there, right? Well, there's more that the Coast Guard can ask you. So this is the latitude and the longitude of the vertex. This is latitude 1 and longitude 1, latitude 2 and longitude 2. Then we've got our initial course and distance. What other kind of stuff can the Coast Guard ask you on other questions? Well, what the third type of question that they can ask is a position along the route. So you can actually calculate points along the route if you're interested in if there's, say there's a fishing spot, or there's a search and rescue case, or a rendezvous that you need to make to get fuel, or traffic illegal drugs, whatever, right? So you can figure out these points along the route. And so if you know the vertex latitude and longitude, you can say, hey, what's the latitude of the point 10 degrees to the west of it? Or what's the latitude of the point, 32 degrees to the west of it, something like that. So we can find these points along the Great Circle route. And so the question that we're going to deal with, it's actually, this is an official Coast Guard question in the database, so it gives you a lot of this information, and then it asks you for the position of point X. 2 markers killed in one session. That's crazy. Point X is located 10 degrees away from the difference from the vertex. 10 degrees west of the vertex. What's the latitude of that point? Right? You can already get the longitude of it, because if you know the longitude of the vertex and you just go 10 degrees west or 10 degrees east, then you're going to have it. But if we want the latitude of the vertex, guess what? There's another formula for that. That's right. Yeah, and so this is out of Bowditch, formula 31. And this one says that the tangent of the latitude of any point along the route is equal to the cosine of the difference in longitude from the vertex times the tangent of the latitude of the vertex. Right, so what is this equation saying? And again, you can look it right up in Bowditch, equation 31. You don't need to memorize it at all. It's all there. The tangent of the latitude of any particular point along the route is equal to the cosine of the difference in longitude from the vertex. So if you know your vertex here, and you know the difference here, if it's 10 degrees in the problem, multiply that by the tangent of the latitude of the vertex, and you get the distance, the latitude rather, not the distance, but the latitude of that point. Is that useful in real life? Yeah, not so much, but it is a Coast Guard question for sure. All right, so it ends up being tangent of latitude of position X is equal to the cosine of 10. That was the amount of degrees west of the vertex that they asked us for in this case, times the tangent, and the latitude of the vertex is right there. So 37.5867. So again, you kind of run through the calculator with all these things, which I did earlier just to save some time because we have another problem that I want to work on tonight. But you can pause the video if you're watching in the future, or DVR it as we go here. Yeah, Alessandro, I'll show you one more time. This is going to be Bowditch, the American Practical Navigator, kind of like the standard text available to you in the Coast Guard text classrooms. Right, so Bowditch Volume 2 includes a whole bunch of tables, but also a really good description of the sailings and all kinds of stuff that you can see on your exams. So not required to memorize by any means. This stuff is available to you if you know where to look. So thanks for the question. So tangent of latitude of the position X is equal to 0.9848. Just ran that through the calculator. And then 0.7697. All right, and so we multiply these two together. Tangent of the latitude of position X is going to be equal to 0.7580. And just like before, what we need to do here is we need to take the inverse tangent of this. And so I didn't draw it on the board last time, but I'll do that now. So the latitude of position X is going to be equal to the inverse tangent of 0.7580. And so to do that in the calculator, type in 0.7580, shift tangent, and you're going to get your answer. And it pops out as 37.163 degrees north. And if we want to turn that into something reasonable, that's going to be 37 degrees. And then I just take the leftover 0.163 times 60 to get 09.8 minutes. So look at all the cool stuff we did with just some information about this Great Circle route, right? So on this Great Circle route, we started out in the northern and the western hemisphere. and we went more north and less west, something like that. So they gave us that. They gave us the initial course and the distance. We were able to find out the vertex for the most poleward point on this trip. So if you weren't prepared, if you didn't pack your cold weather gear, you're heading to a latitude of 37 degrees north. Not that cold, depending on the time of year. But now we know exactly where it is. But we also figured out how to calculate any point along the route, which is a pretty powerful tool if you're doing any kind of voyage planning. If you say you wanted to, how I mentioned you have to continually turn your course to the right if you want to end up at this position. You're not just going to keep the course of 061.7. You're going to continually change it. Well, most commonly what's going to happen on a transoceanic voyage is you're going to pick 10 or 12 waypoints along the way and steer run lines between them. So these waypoints you can figure out using these formulas, or in the modern days we're going to use an ECDIS, an electronic chart display and information system, to do that for us. But we've still got it, the ability to do it in our head. So that's a powerful feeling for sure. All right, let's do one more problem here. Same kind of thing, great circle sailing. And this is the last type of great circle sailing question you can see on a Coast Guard exam. They can ask you the latitude of the vertex, the longitude of the vertex, the latitude of any point along the route, or these last two things, which is the course and distance. So in this case, I'm just going to write up our position here. Latitude 1, and I'm going to put it in decimal notation just to save time, but they don't usually give it to you in that. You have to transfer it to that. So latitude 1 is 33.888 degrees south. Longitude 1 is 18 degrees, 18.385 degrees east. And then latitude 2 is 40.450 degrees north and 73.823 degrees west. So this is a pretty rad one because we're changing hemispheres twice. Truthfully, the east and west hemisphere doesn't really matter at all. But let's draw out what's happening. So we're starting out in the southern and the eastern hemisphere. So that's cool. And we're traveling to a position in the northern and the western hemisphere. So it's going to be, something like that is our great circle route. We're going this way, right? And so the question is asking us, what is the course and what is the distance? If you want to figure out how long this voyage is going to take, we can do that with the distance. If you want to figure out the initial course to steer, you can do that as well. And then you could go forth and do all the vertex stuff if you wanted. But we need the course and distance. So this is a pretty fun problem, and it is one that you can see on an exam for sure. But if you were to take a guess what course you're going to steer, it's probably going to be somewhere around 300 degrees to 330 degrees true. More in there. It's definitely not going to be to the east, definitely not going to be to the south. So that's helpful to know when we're dealing with all that course angle notation stuff. And there is definitely a trick, if you're curious, when you change hemispheres, there's a sign inversion in the course angle notation. So it's a tricky concept. I'll show you that. You may have to press the I believe button, but if you read about it, it'll explain it to you for sure. All right, so in order to do a problem like this, what we actually really need is the difference in longitude. So if they gave us longitude 2 and longitude 1, we can calculate the difference between those two. But just know that we go from the eastern hemisphere to the western. So you can't subtract them like you might think with a difference. It's going to be added in this case. All right, so let's calculate that. 18.385 plus 73.823 gives you 92.208 degrees difference in longitude. All right, so very important. Crossing the hemispheres have to add in this case, but truthfully, if you think about it, you're just looking for the absolute difference between these two here. All right, and then as you can imagine, it's going to be a Bowditch formula. So for this one, it's Bowditch formula 36. You can pull that right out of the book. It's available to you in the test room, so no need to memorize it, just be familiar with kind of where it's found. And the formula for this one, it's kind of long, sorry, but the cosine of the distance is going to be equal to the sine of latitude 1 and sine of latitude 2 minus the cosine of latitude 1, cosine latitude 2, and then cosine of the d-low. Right? So these numbers all get put into the formula, right? And I'm just going to try and save some space. So it's formula 36. You can put that in there. And in order to save a little bit of room here, the cosine of d, when you type all those numbers into the calculators, you end up with negative 0.3618 plus negative 0.0243. Right, so just wanted to highlight this step in the problem, because if you're adding a negative number, what you do is you subtract it. Right, so you type this number in minus that number, and then cosine of your d comes out as negative 0.3861. So then, likewise, to get d, we have to do the inverse cosine. And it's going to come out to 112.7 degrees. So the distance is given in degrees in this case. Right? And so the distance is given in degrees. That's not going to be helpful. But if you know that there's 60 nautical miles in a degree, then you can get your distance that way. So we'll take the 112.7 times 60. Gives you a final distance of 6,262.7 nautical miles. And that's exactly what the Coast Guard book answer is. So it's good. So we're really just interpreting Bowditch Formula 36. Tristan, thanks for the kind words. Appreciate that very much. So Formula 36 out of Bowditch, just remember it's available to you. Know where to look. There's electronic versions of it out there if you don't want to buy the book. And it's just interpreting these questions here. So we get our distance. That's good. 6762 is where it comes out. Sorry. There. A lot of 6s and 7s and 2s in there. All right, so you got your distance. The last thing that they can ask you is, what is the initial course angle? And this is tough because we are crossing hemispheres. So there's just it's a thing you kind of have to memorize. If you're crossing hemispheres, you got to swap the signs in the course angle notation. But another Bowditch formula number 24, right out of Bowditch. It says the sine of the course is going to be equal to the sine of the difference in longitude, which we had found earlier, this d-low thing over here, times the cosine of your second latitude, all divided by the sine of your distance. I will tell you there's another formula out there given that you don't need to use distance on. This one's quicker, so if you have the distance, go ahead and use it. And then you're going to be good as gold. So if you type all this stuff in there, you end up with sine of c is equal to, I'll save you all the drama there, 0.82439. So to get this course, we're going to do the inverse sine of that, 0.82439, and you get 55.5 degrees. And if you remember earlier, what we did is we said we were traveling from the eastern and southern hemisphere up to the northern and the western hemisphere, kind of going this way. Our initial course was going to be somewhere like 300 to 330. So what's the deal with that? What's the deal with that? Right? Well, when you're crossing the hemisphere, we got to make a change, right? So normally you would call this like south, because we started in the southern hemisphere, 55.5 degrees west, but we're going to flip it into the northern hemisphere. Normally it would be that. We're going to flip it to the northern hemisphere to be north 55.5 degrees west when we shift hemispheres. So in that case, what we're saying is it's this angle right here, 55.5 degrees. So 360 minus 55.5 gets you 304.5 degrees true. All right, pretty sweet. So we were able to calculate the course and the distance. 304.5 degrees true. John, I see your question there. You multiply it by 60. I don't have a good reason to explain to you off the cuff. I can get back to you on that for sure. Appreciate the question. All right, so what we did in this problem is we started with an initial latitude and longitude, and they asked us to find the course and the distance. We started with the distance. We used Bowditch formula 36 to do that, and ended up with a distance of 6762.7, and then used Bowditch formula 24 to get the course. Noting that when we get our initial numbers, we have to flip the sign to north in this case, and do the course angle notation that way. So a little tricky, but that's really it. That's what the Coast Guard can throw at you for these Great Circle sailings questions. They can throw you latitude of the vertex, longitude of the vertex, any point along the vertex, course and distance. So 5 variables. But if you deal with Bowditch, know where to look in there. It's going to save you tons of time, and you can deal with these problems pretty quickly. So, John, thanks for watching again. You're going to see a latitude of the vertex question on your test for sure. But for everybody else who's studying for their exam, you can see anything depending on what you're studying for. Like I said earlier, there's a bunch of different kinds of sailings questions. There's parallel sailings. There's mid-latitude sailings, Mercator sailings, plain sailings, and then the these kind of Great Circle sailings as well. So this is going to be the one that we're dealing with tonight, but there are other kinds as well. Luckily, they're all in Bowditch, so good to go. So that's all I got for you tonight. I'll stick around for a few minutes if there's questions in particular, and then we'll be back next week, Thursday night, normal time, for some more navigation problems stuff. All right, have a good night, everybody. Okay, Alex, sure thing. Yeah, I'll email you tomorrow. I'll send both a link to Dropbox and then also some resources to help you study for your exam. So you got 47 days. So it sounds like you're feeling pretty good about stuff, but that's plenty of time to learn some new skills as well. So good luck to you, shipmate. Okay, thanks, Adrian. Take care. Appreciate you watching. Okay, I'm going to sign off from here. You can send any questions, in the future to Chris at practicalnavigator.org. If you're studying for your Coast Guard exams, I got tons of free and discount training resources available to you. videos, courses, resources, anything you want. So check out the website, practicalnavigator.org. Send me an email if you got questions, and then good luck with your studies. Thank you and good night.